All right, we're going to talk about discrete versus continuous. Discrete versus continuous. We're going to use this when we start talking about domain and range as well. If you deal with statistics, you'll deal with discrete variables and continuous variables. But I found this online, and I'm not going to use every single part of it, but I am going to use some of it. So we have it's upside down. We have the discrete units or discrete items versus continuous. All right, let's dismiss. Let's talk about the discrete first. The first thing I could say here is that we can count things that are discrete. All right. If we compare that to continuous, there is nothing to count. All right. When we go from A to B, you can't really count anything. You just kind of continuously move, no breaks. But if we count, if they're discrete, for example, if we count things, we can just do that, right? The collection of the units, I don't know. I don't want to use that part at all. Let's just go down here and take a look at this graph. So if I looked at this graph down here for a discrete function, it's made up of coordinate pairs that don't connect because at 1, I have an output at 1. At 2, I have an output at 2. There is nothing between 1 and 2 for this particular function. There is nothing between it, so I don't count it. Right? If I wanted to talk about that, I could say I could count things like this could be, oh, there it is, the inning versus the number of runs. There is no 1/2 inning. You can talk about outs and all that kind of stuff within the inning, but I'm saying, what about the number of innings? There's either 0 innings, 1 inning, 2, 3, 4, 5, on and on and on. Same thing with number of runs. You don't get, when you're playing baseball, 1/2 of a run. You just get 1 run, or you get 2 runs, or 3 runs, or 4 runs, or 5 runs. There is nothing in between here that you can count that makes sense for this situation, so that makes it discrete. All right. Now, on the other side of that, for continuous, when I look at a distance, for example, there's nothing to count. It's just a straight line there. So if I looked at the function itself, notice that it is a straight connected line. That makes it continuous. So that means the x value, in this case, it's time, and the y value, in this case, is distance, even though time is, let me make this a little bit bigger here so I can get at it a little bit more. If I look at this time, I can go from 1 minute to 2 minutes, but can I break that up into 1.5 minutes? That's a legitimate thing. And can I break that up into 1.25 minutes? So there is a continuous amount of time in between these two numbers and these two numbers and these two numbers and these two numbers. Same thing with distance. This might be 1 foot. This might be 2 feet, 3 feet, but couldn't I have 1.5? And it makes sense. 1.25. So this is a continuous thing here. All right. So continuous versus discrete. Let's just see if we can figure this out. So if I were to, I'm just trying to see if this is continuous or discrete. A stack of coins, is that continuous or discrete? Well, a stack of coins, I would have 1, 2, 3, 4. So I would call that discrete. A bag of apples, what are the number of apples in there? I can count that. That's discrete. A dozen eggs, that means there are 12. That is countable, dozen eggs. That's discrete, sorry. Pearls on a necklace, again, even though there are a certain number of them, I could count them. Those would be discrete. Let's take a look at this one here, over here. The distance from here to the moon, I could say 10,000. I could say 10,002, 10,000.5. It's a continuous thing. Distance is continuous. Applesauce is just a whole bunch of the stuff. You can't really separate that. That is continuous. Don't ask me why. It's there, so I'm just answering it. 60 minutes, right? And if I looked at 60 minutes, that is a time thing, right? From here to here, there are 60 minutes, but couldn't I intercept it at any single point in here? So that's a continuous thing. Time is continuous. And then the area of a circle. That's kind of tricky because the area of a circle, that deals with the formula. I'm not going to do that one. It's pi r squared. So I am not going to deal with the area of a circle. That gets convoluted, so don't worry about it. But continuous or discrete? Discrete are things you can count. Continuous are things that you cannot.